Question 11 says, Brownian motion is the random movement of microscopic particles in a liquid or gas. The statement about the Brownian motion is correct. Brownian motion only occurs when the liquid or gas is heated. Much heavier fast-moving particles that cannot be seen collide with the microscopic particles. Much lighter fast-moving particles that cannot be seen collide with the microscopic particles, and the microscopic particles move to avoid the fast-moving liquid or gas molecules. See, Brownian motion, firstly, it's a random motion. Okay, now because it is a random motion of the particles. Now, what are these particles that we are talking about? We are talking about the random particles like pollen grains or smoke which are suspended in a fluid. Okay, so this motion is caused by continuous bombardment of the particles by the invisible particles. So it is like, for example, if you have pollen grains, then these pollen grains, let's say if you have mixed them with water, then they are being bombarded by the water particles. It's the water particles that are hitting them. Now these water particles would obviously be invisible and they are fast moving. Therefore, the only option that makes sense over here is C. So the water particles, they are fast moving and they are much lighter and they cannot be seen with the microscopic particles. That's why the answer has to be option C. Now, let's look at question 12. Distance between two electricity pylons is 60 meters. The cable that connects the two pylons is 62 meters in length. Why is the cable longer than the distance between the two pylons? So obviously the cable is longer because of the fact that we know there is something known as thermal expansion. So thermal expansion happens during the part when we heat up a substance. That time there is expansion. So we know that if the temperature increases, then that leads to expansion. But we also know that the reverse is also possible. If the temperature is decreasing in colder times, when the temperature decreases, there has to be contraction. So therefore, over here, if I look at all the options, the only option that goes with the statement is option A. It allows for contraction of the cable in cold weather, because in cold weather the temperature would decrease. Let's go to question 13 here. Let's look at question 13. A glass beaker contains a mass of 0.2 kgs of water at a temperature of 20 degrees Celsius. The specific heat capacity of water is 4200 joules per kg degree Celsius. A brass block of mass 0.15 kg is at a temperature of 170 degrees Celsius. The block is carefully lowered into the beaker of water. The final temperature of both the water and the brass is 30 degrees Celsius. What is the specific heat capacity of brass? And we assume that there is no energy lost to the surroundings or to the beaker. Now over here, the basic idea, or what we talk about as the principle of calorimetry, is what we would be using. So the heat lost by brass block over here has to be equal to the heat gained by water, since there is no energy lost. To find out the heat lost or the heat gained, we would be using the formula E is equal to mc delta T, where m represents the mass, C represents the specific heat capacity, and delta T represents the change in temperature. For the heat lost by brass, the mass of brass is given to us as 0.15 kgs. The specific heat capacity of brass is what we are trying to find out, so we'll just take it as C. And the change in temperature for brass. So brass was at 170 degrees Celsius originally, and finally the temperature became 30. So the change in temperature in this situation would be 170 minus 30. For the heat gained by water, we would have mc delta T. So mass here is 0.2. The specific heat capacity is C. And over here, the specific heat capacity of water is given to us as 4,200 joules. So we'll directly take that instead of C. And then for water, we know that originally water was at 20 degrees Celsius. And finally, it changed to 30 degrees Celsius. So the change in temperature here would be 30 minus 20. Let's try and simplify this. So I would have 0.15 into C times 170 minus 30 degrees. That would give me 140 degrees. This has to be equal to 0.2 times 4,200 times 10. Let's rearrange this formula to calculate C, which would be equal to 0.2 times 4,200 times 10 divided by 0.15 times 140. Now let us just put this on the calculator and find out how much it is. This gives me a value of 400 joules per kg degree Celsius. So the correct answer would be option A. Now let's move on to question number 14. Which statement about convection is not correct? Option A. It enables water in a pan on a cooker to get evenly heated. It happens in liquids and gases. It occurs because cooler liquids rise above warmer liquids, and it occurs because the density of a liquid decreases when it is heated. So let us look at option A firstly. It enables water in a pan on a cooker to get evenly heated. So this statement is correct, right? Now for option B, it happens in liquids and gases. This option is also correct. It occurs because cooler liquids rise above. This idea is wrong. Cooler liquids have to sink at the bottom. Therefore, this is the incorrect statement, and hence this is our answer. We can look at option D also. It occurs because the density of a liquid decreases when it is heated. This is true. Warm water or warm liquids would rise up because their density is less. So option C is the correct answer. Let us move on to question number 15. Iron is a better conductor of thermal energy than rubber. Which statement explains this? Let's look at option A. Electrons in iron can move from one part of the iron to another. Electrons in rubber cannot move in this way. So this statement does sound correct, but let's look at the other options as well. Electrons in iron vibrate with more energy than in rubber. See, this statement will definitely not tell you what is a good conductor and what is a bad conductor. It is over here that we have been told that iron is a better conductor. It's a better conductor because it has electrons moving, and rubber probably does not have the electrons moving in the same way, and that is why option A is correct. It has nothing to do or deal with more energy or less energy. In option C, it says the positive particles in iron can move from one part of the iron to another. Positive particles never move, so this option is out of question. Positive particles in iron vibrate with more energy than those in rubbers. Again, positive particles do not vibrate and there is nothing like more energy. So this option is also out of question. We go to question number 16 now. Two metal cans are identical except that one has a silvery shiny outer surface and the other has a dull black outer surface. They each have the same mass of hot water, okay, mass is same, and they are at the same temperature sealed inside them. They are both in vacuum in the darkness of outer space. How does the temperature of water in each one of them change? See, if you talk about a dull black surface firstly, a dull black surface is a better emitter, and a better emitter is always a better absorber because the one who absorbs more will always emit more. So it's a better emitter and a better absorber as well. On the other hand, we have the shiny white surfaces. The shiny silver or shiny white surface that you have over here, that one definitely is not a good emitter, right? So you can simply say it is the worst emitter or the worst absorber, but it's a great reflector. It does not absorb anything, it does not give out anything. Now, let us look at the options. The temperature of the water does not change. See, this is not good. This is not right because the temperature will obviously change because some amount of heat will be radiated out. The water in the black can cools more slowly than in the silver can. This idea is wrong. The water in the black can has to cool faster than in the silver can because black is a better emitter. It will lose heat more quickly because it absorbs faster, it emits faster. Then water in the silver can cools more slowly than in the black can. That is correct because the silver does not emit heat easily. So option C is the correct answer. Let's move on to question number 17. A ray of light reflects from a plane mirror. The angle between the incident ray, and we can draw an incident ray over here, and this can be my reflected ray. And of course, since I have the incident ray, the reflected ray, I should have a normal here. So they told us that the angle between the incident ray and the surface, that means this angle is 35 degrees. Now, if this angle is 35 degrees, then we all know that the angle of incidence is the angle between the normal and the incident ray. And this complete angle here is supposed to be 90. So the angle of incidence here would be equal to 90 minus 35, which gives me 55 degrees. So the angle of incidence here would be 55 degrees. Let's look at all the options. The angle of incidence is 35 degrees, this is wrong. The angle of incidence is 55 degrees, this is correct. The angle of reflection is 70 degrees, that's wrong again, because if the angle of incidence is 55, the angle of reflection should also be 55. Therefore, the correct option is only option B. Let's move on to question 18. Parallel waves in a ripple tank are diffracted as they pass through a gap in the barrier. Three changes that can be made to this arrangement are listed. We can decrease the wavelength, we can increase the amplitude, we can decrease the size of the gap. Which change will cause the shape of the diffracted waves to be less curved? So you want to reduce the amount of diffraction that is happening. See, to reduce the amount of diffraction, you can reduce the wavelength. Therefore, option C is the only correct answer. If you would increase the amplitude, nothing would happen to the diffraction. If you decrease the size of the gap, then the amount of diffraction would increase, and therefore only the first one is the correct one. Therefore, option C is the valid answer. Let's go on to question 19 now. A beam of light passes through vacuum and then enters a transparent liquid. The diagram shows the path it takes. The light travels through the vacuum at a speed of 3 into 10 to the power 8 meters per second. What is the speed of light in the liquid? Now, we know that if we want to calculate the refractive index of the liquid in this situation, then the refractive index could be written as sine I by sine R, that is sine of the angle of incidence to the sine of angle of refraction. Or I could write the refractive index as the speed of light in vacuum to the speed of light in the liquid. Now, over here angle of incidence is 40 degrees, so I'll have sine of 40 degrees. Then I have sine of refraction, so that is sine of 25 degrees. Further, the speed of light we already know, it is 3 into 10 to the power 8 meters per second in vacuum, and the speed of light in the medium is what we are trying to calculate. Now when you put sine 40 and sine 25 on the calculator, please make sure that your calculator is set to degrees. Many students make this mistake that the calculator is set to radians and they substitute in degrees and hence achieve the wrong answer. Now when you put this over the calculator, the answer comes out to be approximately 1.5209 is equal to 3 into 10 to the power 8 meters per second divided by V. And now when I rearrange this to calculate the value of V, I get V as 1.97 into 10 to the power 8 meters per second. Now when I will round this off, 1.97, it will come out to be 2 into 10 to the power 8 meters per second. So the correct option here would be option B. Lastly, let's move on to question number 20. Which statement about a thin converging lens is correct? All rays of light refracted by the lens pass through the principal focus. This idea is wrong because there are other rays which can pass through the optical center. There are rays that can become parallel to the principal axis after refraction. So this statement is not correct. All the rays initially parallel to the principal axis of the lens are refracted through the principal focus. This statement is correct. So if I have a lens and you have a ray of light that is coming parallel to the principal axis, let's say that this is my principal axis, then this light ray we know will pass through the focus. So option B is correct. We can look at option C as well. The focal length of the lens is the distance between the image and the focus. That's wrong. Focal length of the lens is the distance between the object and the image. This is also wrong. Focal length of the lens is actually the distance between the lens and the focus. Okay, I hope you understood all these 20 questions. If you understand all of them, then do subscribe to my channel and watch out for the next part of the video.